Hello, welcome to another class with Mathema. And in today's class, we shall continue with our topic, quadratic equation. And what we'll be looking at under quadratic equation in today's class is line of symmetry. Let's first understand what we mean by line of symmetry. A line of symmetry is a line that divides a shape into two equal parts. In other words, a line of symmetry is what gives you two halves of a shape. For example, in a square, remember the parameter or the property of a square. We say that all sides of a square are equal. So, if we have a line through this diagonal, we can successfully divide this square into two equal parts. So this is a line of symmetry. If we also make another line through this diagonal, we can as well have two equal parts of a square. So this is another line of symmetry. A line through like this can also divide this square into two equal parts, and another line this way can divide this square into two equal parts, a part here and a part here. So we say and conclude that a square has four lines of symmetry. So we say a line of symmetry is a line that divides a shape into two equal parts. So you must note that different shapes have different lines of symmetry. This, for example, we have checked for a square, and we discovered that a square has four lines of symmetry. If you talk of an equilateral triangle, meaning that all sides are equal, and it means that what? The angles are also equal. So if I must get how many lines of symmetry will this equilateral triangle have, then a line through here, since this side is equals to this side and equals to this side, this will successfully divide this triangle into two equal parts. Another line through this way can divide this triangle into two equal parts. And if I make another line through the apex of this triangle, I can successfully also divide this triangle into two equal parts. So I'll say that an equilateral triangle has three lines of symmetry. Okay, and there are some shapes that may not have line of symmetry. That is, it is impossible to draw a line through them that will successfully divide them into two equal parts. So let's bring this knowledge to a quadratic graph. A quadratic graph, we have studied in the previous videos or lessons that it may be a U shape or it may be what? N shape. In other words, this is when A is greater than 0, that is, A is positive from our form AX squared plus BX plus C equals 0. This is the general form of a quadratic equation. So when A is greater than 0, that is, A is positive, such as 1, 2, 3, we say that the quadratic graph will have a U shape. And when A is less than 0, that is, the value of A is negative, we say that a quadratic curve will be N shape. In this shape that we have, a line of symmetry simply means a line that runs through the quadratic curve, or what we know as parabola, such that it divides this curve into two equal parts. A line of symmetry of a quadratic graph or equation is such that run through the quadratic curve and therefore divide the quadratic curve or the parabola into two equal parts. Now let's study this line of symmetry. One thing we can see here is that line of symmetry will only cut through the x-axis and not on the y-axis. It will cut the x-axis, that is, if we must get the value of this line of symmetry, we can only find the value here where it cuts the x-axis. And if we must find the line of symmetry in this N-shaped quadratic curve, we can see that what the line of symmetry will be where it cuts the x-axis. Don't forget, to get the solution of a quadratic equation on a quadratic graph, we say that the solution is where the curve cuts the x-axis. Suppose the roots are alpha and beta. So alpha will be this point where this curve cuts the x-axis, and beta will be this point where this curve cuts the x-axis. So also our line of symmetry is where this line, which divides this curve into two equal parts, cuts the x-axis. So the line of symmetry is never found on y-axis but on x-axis because it runs through the x-axis. It cuts through the x-axis and not the y-axis. Another thing that you must note that we are going to make reference to in the next video is for us to note that this line of symmetry will definitely pass through the peak of the curve. In this case, we have a maximum point because this looks like a mountain. So the peak, if we must divide this curve into two equal parts, if we must draw a line through this curve such that it will divide it into two equal parts, and such line that is called a line of symmetry must be such that runs through the peak of this curve. And that line must be such that runs through the minimum point of this curve. So the line of symmetry falls at the middle of this alpha and beta because it must cut the curve into two equal parts. So it must run through the middle of alpha and beta. It must be such that run through the middle of alpha and beta. So if this point truly is our line of symmetry, it means that if we can find the value that is at the middle of alpha and beta, that is our line of symmetry. If we can find the value at the middle of this line of this solution, of this curve, of this alpha and beta, the point of value that is in their middle is our line of symmetry. So in other words, our line of symmetry, okay, line of symmetry, let's represent it with LOS, equals the middle point of alpha and beta, or the midway between alpha and beta. And we can only get the middle point by saying that alpha plus beta, and then we divide by 2. So to get our line of symmetry, we have to add the roots of the quadratic equation and then divide it by 2. Let's take an example. Note that this is when the roots of the quadratic equation are known. It is very easy for us to apply this method to find the line of symmetry only when we already know the roots of the quadratic equation. That is, the roots in this case are alpha and better. Let's take an example to quickly understand this. An example, given that the roots of a quadratic equation are -2 and 1. Okay? Find the line of symmetry, or rather calculate the line of symmetry. So from this analysis, we have seen that we can get our line of symmetry by adding the roots of the quadratic equation together and then divide it by 2. So if we must solve this, okay, we can say that our solution to that example will be line of symmetry equals alpha plus beta over 2. In this case, let's take our alpha to be -2 and our beta to be what? 1. And then we say -2 plus 1 over 2, and that will be -1 over 2. Our line of symmetry in this case will be -1 over 2. Don't forget that we are able to use this formula in finding a line of symmetry because we already know the roots of the quadratic equation. What happens in a case where we are being given a quadratic equation and we are being asked directly to find a line of symmetry? Solving the quadratic equation to first get your roots before you can get your line of symmetry will be a waste of time. So let us see how we can directly find a line of symmetry if we are being given a quadratic equation without knowing the roots of the quadratic equation. And that is what we want to do right now. So let's take an analysis. Recall that from our lesson on sum of roots and product of roots, we say that a quadratic equation can be written in the form ax squared plus bx plus c equals 0. And then we say that x squared minus alpha plus beta x, okay, plus alpha beta equals to 0, where this represents the product of roots and this represents the sum of roots. Okay? And easily we can say that if we must turn this to something like this, we say that we can have ax squared over a plus bx over a plus c over a equals 0. So a cancel a. So in that lesson, we are able to compare this now with this. Okay? So by comparing this with this, well, we now have x squared plus b over a x plus c over a equals to 0. So if we compare this directly with this, we will see that our sum of roots, which is minus alpha plus beta equals to b over a, and then sum of roots alpha plus beta equals to minus b over a. So you recall from those previous lessons that sum of roots is equals to minus b over a. So because we know that our sum of roots is minus b over a, let us substitute minus b over a for this sum of roots, which is alpha plus beta, in this line of symmetry formula. Okay? So let us substitute that and see how we can generate another formula for a line of symmetry. So now that I know that, recall that alpha plus beta equals minus b over a. So I can say LOS, line of symmetry, equals alpha plus beta divided by 2 and equals alpha plus beta okay, divided by 2. Let's make this over 1, okay, and then alpha plus beta is minus b over a times 1 over 2, and that will be minus b over 2a. Therefore, line of symmetry equals alpha plus beta divided by 2, and is also equals to minus b over 2a. So it is important that we should note in this case now that our line of symmetry can be calculated using alpha plus beta over 2 or using minus b over 2a. Now let's note, when can we use this formula and when can we use this formula? I have mentioned earlier that these, obviously looking at it, these are the roots of the quadratic equation, can only be used only when we know the roots of the quadratic equation. But when we are not being given the roots of the quadratic equation, only being given the quadratic equation itself, then we can directly apply this formula. So let us check. From the previous example we did, when we are being given the roots as minus 2 and what 1, finding the line of symmetry, we got minus 1 over 2. So let us see the equation that led us to getting the root as minus 2 and what 1, and then we'll solve it as if we are being given that equation to find our line of symmetry. Okay, that's what we're about to do now. Obviously, we can write, okay, quadratic equation as x squared minus alpha plus beta, okay, plus alpha beta equals 0. X squared minus 2 plus 1, okay, plus minus 2 bracket 1 equals 0. So x squared, okay, plus 1, this is x, don't forget there's x here, that's x squared minus alpha plus beta x plus alpha beta. So this is minus 2 alpha plus 1 beta, okay, and we know that if I'm to write that, that will be minus 1x plus minus 2 times 1 will give me minus 2 times this, I'm going to be having minus 2 equals to 0, and this will give me x squared plus 1x, which is x, minus 2 equals to 0. So this will give us this equation. So let's take this as a question now. Example: given the quadratic equation x squared plus x minus 2 equals 0, calculate the line of symmetry. So this is a question where we are not being given the roots of the quadratic equation, but we are being given the quadratic equation itself to find the line of symmetry. So easily we can say, since we are not being given the roots, we cannot apply alpha plus beta over 2, but we can only apply minus, okay, b over 2a. So we apply this because we are not being given the roots. So we can say line of symmetry equals minus b over 2a. So from this question, our a is 1, okay. If you compare this to ax squared plus bx plus c equals to 0, your a is 1, okay. Your b is also 1, all right. So we don't need c, but let's just state it is minus 2, but we don't need c. So putting all these values accordingly to this formula, that is minus, our b is 1 over 2a, our a is 1. So minus 1, 2 times 1 will give us 2, and that is minus 1 over 2. So here, we are being given the roots. We calculated using alpha plus beta over 2. And here, we are being given just the quadratic equation, and then we use this formula, and then we got the same what? Answer. So in this class, what we have done is finding the line of symmetry of a quadratic equation. Either we are being given the roots or we are just being given the quadratic equation itself. So I implore you to please kindly share out this video with other students around you. Try as much as possible to watch my previous videos on quadratic equation. Comment and let me have your feedback on how you understand what we have done in this class, in this video. And please like, share, subscribe if you have not done so, and turn on the notification bell. Till next time I will be coming your way in another video. Remain blessed, and I wish you all the very best in your education. Bye for now.